Today we are going to look at polyatomic compounds. We are going to know how to take names and convert them into chemical formulas, and then take chemical formulas and convert them into names. Before we begin, we need to talk about polyatomic compounds. Poly refers to more than one, and atomic refers to atoms. So these are compounds that have more than one, a combination of more than one atom. The best way I can explain this is to just jump back in our thinking all the way back to simple binary compounds when we were talking about like calcium and say iodine. When we were to put those two together, we'd know that calcium is +2 and this is -1. They'd go together with 2 iodine for every 1 calcium, and you'd get a formula CaI2, right? And this was just one entity, and this was just one entity. It was a Ca and it was an I, and they came together. Let's just do a similar thing, but instead use Y as a variable. It could represent anything, and we'll give it just to arbitrarily pick +3, and we'll take X as another variable, as an anion, and we'll just give it a -2 charge. And if I asked you to do this, you'd come up with the right answer. You'd need 2 of these and 3 of these to make it neutral, or you'd crisscross and you'd have Y2, X3. And so in this example, it doesn't even matter what is in these little blocks, CaI. It doesn't matter. You're only looking at the charges of those spheres in order to create a chemical formula. We're going to suggest to you today that this is no different. We'll do Ca, and let's pick NO3, and we're just going to put that in brackets. And I'm going to look up its charges. Ca has a +2, NO3 is a -1, and I find this in the backside of your periodic table. And you wouldn't look for these in the periodic table and call this like calcium nitrogen oxygenide. Rather, you would recognize, okay, there's more than one together in a group, so I'm going to have to look in the backside of the periodic table, and that's a chart of polyatomic ions. And so just like we did up here, you can kind of think of this as a unit put together all by itself, and you don't even really need to even think about what's in there. Just like we did in up here, you just need to concentrate on the charges and how many of each of these do I need to make it neutral. So if I asked you that question and you knew this was -1 and that was +2, you would need 2 of these, right? So let's draw it. Na and NO3, that's what was in brackets, and you need 2 of them. Right, it's important to keep these in brackets when there's more than one, because it indicates that there's 2 of all of this which is in here. And this will become important later when we're balancing chemical equations. I'm going to do a few examples here, and you guys can go ahead and try some. Well, let's look up here, magnesium sulfate. So magnesium sulfate 1A. Magnesium, I look it up in the periodic table. And again, you got to watch out for multivalent ions here as well when you're doing this on a test. So magnesium is not multivalent, it's just +2. And then sulfate, I look that up. So I recognize that it says 8, sulfate. If they end in IDE, you might want to check out the periodic table. There are some that aren't monoatomic, but there are some that are polyatomic, like cyanide or hydroxide. Those are 2 common ones that are polyatomic. If they end in 8 or ite, you could probably find them on the backside. And so we look on the backside and you find sulfate is a -2 ion, SO4 with a -2. And so you ask yourself this question, the same question we've been asking ourselves. How many of each of these do I need to make it neutral when I put these together? Or you can crisscross and reduce if you'd like, but this would be MgSO4. Now, training wheels on, you can leave those brackets on there, but you don't need them, and you drop them later on. So on our final unit test, you wouldn't show me the brackets, but right now, it's probably a good idea if we do keep them in brackets so that we kind of maintain the idea that they're all together. Let's do B. sodium chlorate. NaClO4. So sodium, which is a +1, and chlorate, which is a -1. Again, 1 to 1. I only need one of each. So you have sodium chlorate. Let's do C, which is aluminum nitrate. Aluminum, looking up in the periodic table, is a +3, and nitrate is -1. So how many of each of these do I need to make it neutral? Well, I'll need 3 of the nitrates and 1 of the aluminum. So Al. We need brackets here. And you have aluminum nitrate. So go ahead and try a few, and if you need any help, please come and see me.